Good day everyone. Our topic for today is recognizing and analyzing geometric shapes. So what is geometric shapes? Geometric shapes are not only shapes like triangle, rectangle, and square, but are precise, close figures with boundaries of lines, curves, and points used in geometric and design. Objectives. At the end of this lesson, the student will be able to first, analyze and recognize fundamental plane and solid geometrical shapes. Number 2, differentiate polygons and classify them as simple and complex, convex and concave, and regular and irregular. 3, identify different types of three-dimensional solids like polyhedra and non-polyhedra. Number 4, apply Euler's formula in understanding polyhedra. Good day everyone. Today, we're going to explore the world of geometric shapes. Now before we start, let me ask you something. Have you ever looked around and noticed how many shapes we see every day? From the buildings, to road signs, to even the cell phones you're holding. They're all made up of shapes. That's how important geometry is in real life. So in this lesson, we'll be learning how to recognize and analyze both planes figures, 2D shapes, and solid figures, 3D shapes. By the end of our discussion, you'll be able to identify the different kinds of polygons, classify them properly, and even apply formulas like Euler's formula in solid geometry. Sounds exciting, right? So let's begin. So let's talk about plane shapes, 2D shapes, or polygons. First, let's talk about polygons. A polygon is simply a flat, two-dimensional shape with straight sides. The name of a polygon depends on how many sides it has. So if it has 3 sides, we call it a triangle. With 4 sides, it's a quadrilateral. 5 sides, a pentagon. 6 sides, hexagon, and so on. So the key idea is polygons are flat shapes made of straight sides and closed figures. They don't have any curves. So there are types of polygons. Now, polygons can be grouped into different categories. So let's check them out. First, simple versus complex. A simple polygon does not cross over itself. So imagine a triangle or a square that the sides just met at the corners. And a complex polygon, on the other hand, intersects itself. First, simple versus complex. A simple polygon does not cross over itself. So imagine a regular triangle or square. The sides just meet at the corner. A complex polygon, on the other hand, intersects itself. So for example, star shapes that the sides cross each other. So the key word here is that the simple polygon do not intersect itself while the complex polygon intersects itself. So second, convex versus concave. A concave polygon has no angles pointing inwards. That means if you draw diagonals, they will stay inside the shapes. Example, a square or a regular hexagon. Then a concave polygon has at least one angle that points inwards, which is greater than 180 degrees. Think of a star with inwards dent. So based on the illustration, the convex has no angle inward while concave has pointing angle inwards. So third, regular versus irregular polygon. A regular polygon has all sides and all angles equal. A square is a perfect example. An irregular polygon does not have equal sides or angles. For example, a rectangle. The opposite sides are equal, but not all 4 sides are the same. So let's delve into angles and polygons. Polygons also have interior and exterior angles. The interior angles are the angles inside the shape. So the formula for finding the sum of all interior angle is equals to n minus 2 times 180 degree. And each angle, if regular, is equal to n minus 2 times 180 degree divided by n. And take note, the n represents the number of sides of the polygon. So sum of exterior angles of any polygons is equal to 360 degree. At each vertex, interior plus exterior is equal to 180 degree. So here are the examples. For heptagon, so we have given formula to follow to get the sum of interior angles for heptagon, so which is n minus 2 times 180 degree. And the number of sides of heptagon is 7. So let's solve. N minus 2 times 180 degree is equal to 7 minus 2 times 180 degree. So let's solve first the closed and open parenthesis, which is the 7 minus 2 is equal to 5, and bring down the multiplied by 180 degree. So 5 times 180 degree is equal to 900 degree. And after that, to get the measurement of each angle for regular polygons, the result of the sum of interior angle, which is 900 degree, is going to be divided by the number of sides, which is 7. So we have 900 degree divided by 7. So if we try to solve the triangle, so we have 900 degree divided by 7. So 900 divided by 7 is equal to 128.5714 degree. So the sum of internal angles of heptagon is 900 degree, and the measurement of each angle for regular polygon is 128.5714 degree. So if we try to solve the triangle, quadrilateral, pentagon, and hexagon, the only thing to do is the same. Follow the given formula to get the sum of internal angles and the measurement of each angle.
Solid shapes, or we call that 3D shape. Now let's move from flat shapes to solids. There are 3-dimensional shapes, meaning you have length, width, and height. Solids have volume. how much space they occupy. Surface area, the total area of all surface. Imagine how much paint you need to cover it. There are two main types of solid, polyhedra and non-polyhedra. Polyhedra are solids with flat surface. Each surface is a polygon. Example include prisms, pyramid, and the platonic solid. Plates are the special group of polyhedra where all faces are the same kind of regular polygon and all corner and edges match up in the same way. There are exactly 5 platonic solids in existence. Number 1, tetrahedron made of 4 pieces. Number 2, cube or hexahedron, 6 square pieces. Number 3, octahedron, 8 triangular pieces. And number 4, dodecahedron, 12 pentagonal pieces. And last number 5 is icosahedron, 20 triangular pieces.
Now, here's something amazing. No matter which polyhedron you take, there's a formula called Euler's formula that always works where F equals face, V equals vertices, and E equals edges. This formula helps us check if our counting is correct. Number 2 is prisms. A prism is a polyhedron with 2 identical bases connected by rectangles. The cross section is the same all the way through. If the base is a triangle, it's a triangular prism. If the base is a pentagon, it's a pentagon prism, and so on. For common example of prism shape is a rectangular prism and hexagonal prism. Prisms can also be classified as regular or irregular depending on the shape of the base.
Number 3, pyramids. A pyramid has a polygon base on apex. That's the top point or the triangular faces met. If the base is a square, that could be a square pyramid. Base is a triangle, that could be a triangle pyramid. Base is a pentagon pyramid, and so on.
Number 4 of our topic. Not all solid have a flat base. Some have curved surface. That's what we call non-polyhedra. Example like cone, like an ice cream cone. It has a circular base and curved surface. Cylinder, like a soda. Two equal circle connected with a curved surface. And Taurus, that's a donut shape, curve, all around curved surface. That's all of our report. Thank you.